Welcome to Outlaw Woodworking. Today I'm going to show you the importance of using parameters in Fusion 360. Now I'm not originally I did a video where I showed drawing the cabinet and everything at the same time, but it ended up a really long video, and it didn't really what you need to know is the parameters. And so I'm going to go through how I created these parameters, and then I'm going to show you how they work with cabinetry and why it's so important to draw with parameters. Basically what you end up doing, you end up creating a parametric cabinet. Now if you see this cabinet on the left, this is a standard cabinet, 24 inches. It's 24, currently it's 24 wide, 24 deep. In this particular case it's 36 to the bottom of the toe kick. Now the way I drew this is I basically, instead of drawing something with dimensions, I started off with these parameters. So I started off box height, 32 inches, box depth, 24 inches, box width, and I just went down the line and created these parameters. And then every time I drew anything, now I'll show you, I'll give you a short example here. So let's go ahead and we'll act like we're drawing something here. And I'm going to go over here away from the cabinet. But let's say I create a rectangle here. Instead of typing in the dimensions, so you see the highlighted part right there on the left, I would do box height, and basically I would scroll down, enter box height, hit tab, then I would do box depth right there, 24, hit tab, hit enter, and there's my box. And then after that I would go on the bottom and I would hit that right there, and I would start out with toe kick, and I've already got that labeled as toe kick 4 inches. Then I would tab, I would do box depth right there, enter, and then I would minus toe kick. So I do box depth minus the toe kick, and that would create my little toe kick right there. So if you highlight, and I should have hit enter, but see there, right there is your toe kick. So that's basically how you use your parameters as your constraints of how you're going to do the drawing. Okay, let's go back to, I'm going to erase this, get it out of the way. Let's go back to the parameters so I can show you what it's capable of. And so we'll move this cabinet a little bit, and I'm going to go ahead and 3D it just a little bit. Let's put it like right there so you can see kind of inside of it. And we'll get rid of that origin, and we'll get rid of the sketches, and we'll just leave all that alone. Okay, so if you were to look over here, so currently right here I have three drawers, but if you change that to 6 drawers, hit enter, it automatically changes the spacing. This is the brilliance of using a parametric drawing. And you can, so I've just added 6 drawers. Now let's go ahead and make it wider. So, and you don't have to redraw, you don't have to redraw the whole thing. And this is really the brilliance of drawing in constraints. And let's go over, so I'm going to change this width back to 24 so I have room to spread this out a little bit. We'll leave the 6 drawers in there. So if you look at these parameters, and I'll try to highlight some of the stuff that's really important. Get rid of this warning down here. So this is what I used to create this cabinet: box height, box depth, box width, plywood thickness, and I did three different plywood thicknesses. I did 3/4 inch, which is the box this box skin, half inch. Half inch was I did half inch for the drawers, and then I did 1/4 inch for the drawer skins. And so you got 3/4, 1/2 inch, and plywood thicknesses. I have box dado, and my box dado is the dado on the outside box for the sliding in the 1/2 inch on the back. Then I switched over to drawers, and I did drawer width. Now here's where you need to put in this calculation if you want to do a parametric drawing like this one. So on the drawer width, you have an important calculation, and let me see if I can make this wider so I can read it to you. So the drawer width, you type in this calculation right here, and this is box width minus plywood thickness, so 3/4 inch. So you want to do box width minus plywood thickness times 2 minus slide spacing times 2. That's an important calculation. The next calculation you're going to put in is this one down here, and let me make this wider so you can see that. Now this one's a little bigger. So right here it's going to be box height. Well, you're going to put a couple parentheses right there. And then you're going to put box height minus plywood thickness times 2 minus drawer spacing within a parenthesis. And then you're going to do minus drawer spacing times drawer numbers, and then put another parenthesis, and then you're going to do divided by parenthesis, drawer numbers, a parenthesis. So those are the two big calculations that are important to put in there. And then, you know, we go down here, we got our box dado. So you have a drawer width with this calculation, and I'll type it up here in big letters for you. And then you got the drawer height. So the drawer width and the drawer height, they require these important calculations. Then you go down to drawer spacing. I use 1 inch as my spacing. The slide spacing, 1/2 inch. So you want, whenever you're drawing, you want to use that spacing. Like if you're doing a drawer, you're drawing a drawer inside of the box. When you do your subtraction, you're going to subtract plywood thickness, slide spacing thickness to come up with that, to make it click where you want it to click. Then you got drawer dado, drawer depth, toe kick, and drawer numbers. Now, the other thing, that there's a couple other, so you got these two calculations which are important, and then you can pretty much do all your other calculations, just start off with anything you want. You know, you can start off, if you're doing an 18-inch box, that's fine. You can start off anywhere you want right here. But these two calculations end up important as far as making the whole thing work. The other calculations, so we'll get out of there. The other calculations is in this rectangular pattern. So right over here, so I just jumped into this rectangular pattern, and because these are, the box width, if you didn't have any drawers in here, you wouldn't need to even put these calculations in. But because we're changing the parameters of a box and drawers at the same time, you need to come over here and you basically select one of your boxes in the beginning, just like it's highlighted right there. And over here, your quantity, you type in drawer numbers, and then in distance, this is the critical one, distance, you're going to put minus box height plus drawer height plus plywood thickness times 2 plus drawer spacing times 2. And that's really important. And then on your axis 2, just have one direction, and you can see all those things. All that stays just like it is. Then when you have this created, so right now that's a 24-inch box, but let's say, I got a call and I need a plan cabinet that has a bunch of small drawers, but it needs to be wider. So I would go over here and I go, okay, let's do a 48-inch wide, and let's do drawer numbers 10. That way the guy could lay plans in there or whatever he wants, and let's see if that works. And now you see that just created perfect spacing and made a plan box. And you can basically, you can do that all day long. You can, so let's leave those 10. Actually, let's change that a little bit. Let's just put 6 drawers, but let's put our box height in 96 inches, a full height deal, and go ahead and hit OK. Now you have a tall cabinet. Of course, you couldn't reach up here to get these drawers, but this is just an example. Anyway, so I'll highlight those formulas for you, and I'll attach them down below. And give this a try. Parametric modeling is a really good tool. Anyway, thank you very much for watching. Please subscribe, like the video, and I will see you next time. Later.
There he goes, it's a working man. He's trying to make a living any way he can. And he'll break his back for $1 or $2. Oh, there ain't no shame in what he do.